All right, we are rolling. Welcome back, everybody, from spring break. And hopefully, everybody had a nice restful break. Did some fun stuff with family, and maybe got outside and did some things. It was a crazy week weather-wise. It was do some paddling out there, and it was 70 degrees one day. A couple days later, we had snow. Almost broke out the skis to go skiing. So some crazy weather, but we did have some nice days. Hopefully, it was restful for you guys. Everybody's healthy, ready to get back at it. Some cleanup work. A lot of work is still missing out there. Get it submitted so I can put it in the grade book as completed. Please read the instructions. We've got some issues with people not reading the instructions carefully. If you do have questions about anything, please text me, or not text me, but email me, and I can get back to you, or write a comment on a homework or something that'll be submitted to me by email. I'll get back to you as soon as I can. This week we're going to be doing review. If you would look at today's assignment for the week, this week, it's review week of chapter 1, but also some cleanup work yesterday was assigned. Again, work that wasn't completed. I also put comments and marked some things wrong. Please correct those. Some stuff with labeling and units and some things of that nature. There's a sheet that explains what to do and how to clean up that work from the previous week. So review. We're going to go all the way back to the first section of this chapter, review chapter 1, way back to motion, reference points. We'll get into video on speed exercises tomorrow. The following day, I'll get into graphing. We'll do an in-depth review of graphing since now I'm on video now, and it's more detailed explanation of things. So we're kind of backtracking and doing some review. And then acceleration. I had the acceleration video already that was out there. Hopefully you watched it and got a good handle on that, which it did. Your homeworks looked pretty good. Some cleanup on labeling and things like that. But for the most part, they did real well on that. But I want to step back and do a review this week, starting with in your textbook on page 6 and 7. We talked about motion. When the distance of from one object to another is changing, something is in motion. So you can tell that you can simply measure things in units of measure for kilometers or meters to see how far they've traveled. You can also use a reference point. What is a reference point? Or what can you use as a reference point? Tells you that an object is in motion. That's the object that you're going to measure it against. So if you're in your car going down the road at 35 miles an hour, you're sitting inside the car, it doesn't look like you're moving, but how can you tell that you're moving? By using a reference point. What reference points could you use? Yes, right. A tree on the side of the road. Anything else? Houses that you're going by, that's a reference point. Other cars, signs, bridges, anything that's nearby the road. How can you tell that I'm in motion? What's your reference point that tells you that I am moving? Right, the wall behind me. Either the house is moving because of an earthquake, or I'm moving, and I would hopefully that it's me that's moving. So the wall is your reference point that tells you something is in motion. On the next page, 8, 9, we get into the metric system, which is what I want to just focus on today. Metric units and converting metric. So that's a should be refresher. I know you've studied this in the past. We're going to go to the magic screen. Ooh, high tech, huh? So measurement for length, right here. The base unit is meters, a meter stick, a little bit longer than a yardstick. And that's the basic unit of length. It can also be broken down into centimeters. We'll get into centimeters, which is about the width of your little finger. That's about a centimeter. A kilometer, that's a kilo is the base unit, means 1,000. So a kilometer would be 1,000 meters, or a little over a half a mile. Light year, we're not going to get into that today. Volume, if you want to measure volume is the three-dimensional, how much space something takes up in three-dimensional space. Base unit is liter, okay, like a liter of pop, liter of water. You can put a prefix in front of it, milliliter. A milli Means 1/1000th. So 1/1000th of a liter would be a milliliter. Not much. Not much. Not much fluid. Or a cubic centimeter. If something's not like a liquid, if it's a solid, you could measure it in cubic space. Cubic centimeter. Remember, so centimeter by 1 centimeter. So length times width times height gives you the three-dimensional cubic volume of something. You measure a piece of wood or something. And then mass. The base unit again is grams. A gram is about the mass of a paper clip. Not very much mass. We don't want to say weight because in science we call that mass. Kilograms, again, kilo means 1,000, so 1,000 grams would be 1,000 paper clips, about 2.2 pounds to compare it to American units. American. And a milligram is about the mass of a paper clip. That's a 1/1000th of a gram that's what milli means, 1/1000th. So 1/1000th of a gram is a milligram. You see that in vitamins and food products, the milligrams. So your base units and weight, we'll touch on weight. We're not going to use weight yet till chapter 2, but weight is based on gravitational pull. And that's measured in Sir Isaac Newton's. We just call it Newton's, named in his honor, the unit. So again, your base units we're going to be using today, the meter for length, the liter for volume, and the gram for mass. And the prefixes we'll tack in front of them to break that down. All right, back to me. I'm going to flip over the prefixes a little bit. Back to the magic screen. So at the top of the page, let's go right in the middle. In the middle, you've got your base units. Oops, let's go there. Here's your base units. I'm going to do it this way. Your base units are your liter and meters and grams. Okay, meters and liters and grams. Oh my, that's your base units. Has a value of 1. Okay. Remember I mentioned that milli is 1/1000th of a base unit. A milligram, milliliter, milliliter. Every unit goes up by a unit of 10. This is all base 10. Okay. Centi is about 1/100th of a meter, or centi of 1/100th of something, of a meter, centimeter, centigram, centiliter. And then there's deci. And then we go to the base unit. Still going up by base 10. Now we multiply by 10 to get a decameter. And then 10 of those equals a hectometer. 10 of those equals a kilometer. Kilo is equal kilo. The prefix means 1,000. Has a value of 1,000. The nice thing about the metric system is base 10. So to convert, to go from kilos to deci, from kilometers to centimeters, let's say, you're just sliding the decimal point. Every place value represents a power of 10. So you're either going up or down the scale by sliding the decimal point from milli to centi to deci to base unit, meters, liters, or grams, to deca, hecto, kilo. Okay? So everything's base 10, which is nice. Easy to convert metric. All right. So here it is. Uh-oh, we're having some technical problems here. Can you guys see that? The magic screen is giving me issues. Let's skip. Oh, there we go. Just stand in front of the light. Sorry about that. Okay, so horizontal pattern. We've got milli, so 10 millimeters, 10 millimeters equals 1 centimeter. 10 centimeters equals 1 decimeter. 10 10 decimeters equals 1 meter, like a meter stick. 10 meters, or 10 meter sticks, if you will, equals a decameter. Okay, 10 decameters equals 1 hectometer. We don't use these very often, decameters and hectometers. Those prefixes aren't used, but they do take up a place value, so you have to have them. And then 10 hectometers equals 1 kilometer. Okay, and again, we can go 10 milligrams equals 1 centigram. Centigrams we don't use that often, and so on and so forth up the scale. Or milliliter, 10 milliliters equals 1 centiliter. 10 centiliters equals 1 deciliter. 10 deciliters equals 1 liter. Okay. And a lot of these units we don't use, but the more common ones, you see millimeters, milligrams in medicine and food food labeling on products. Meters, obviously meter sticks. Liters of pop, 2 liters of pop. Grams, milligrams, we'll see in medicine. Kilo, either you can say kilometers or kilometers, either way, but when you travel around, you go to other areas, and you'll see kilometers. It's 100 kilometers to Toronto or something if you're up in Canada. Okay. Okay, so back to the next screen. Hopefully that'll show. There we go. Shows. This is one of the works that you did. One of the homeworks that you did early on. Metric Mania. Okay, and it has how to write some of these conversions. The kilogram. Actually, there's a kilogram right there. Lowercase k, lowercase g is a kilogram. Meter is a lowercase m. A gram is lowercase g. Milliliter is lowercase m, capital L, call those milliliters. Millimeter is mm, lowercase, millimeter. And liter, plain old liter, is capital L. Kilometer, km, lowercase km, I don't think I have one on here, I'll have to search around. Centimeter is right here, centimeter. And milligram, right here, milligram. Now here's my kilometer over here, okay, or kilometer, I don't care how you say it. Okay, so there's basic abbreviations for those. And then at the bottom you had to convert. There's a video for you to watch about how to convert from one unit to another. I'm just going to do that for you right now with a little mnemonic device. Hopefully that'll come up on the screen. Almost. I think I have them all. Okay. So again, here's our units. Millimeter, we're just going to use meter as our base unit. Millimeter, centimeter, decimeter, meter is your base, and that again can be meters or liters or grams, oh my, either right in the base units. Decameter, hectometer, kilo, meter. But these can all be, milliliter, kilogram, right, or whatever unit you're going to use, but these are the prefixes with meters as the base. Okay, so a little mnemonic device to remember. You need to remember these in order. K, H, D, B for base, D, C, M. So kilo, hecto, deca, base unit, meters, liters, or grams, deci, centi, milli. And a little mnemonic device that we always use to remember these by. King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. So kilo, hecto, deca, by is your base unit, meters, liters, or grams, deci, centi, and milli. And that is King Henry, and that is chocolate milk. So you need to remember those letters in order. You need to have all the letters there, because remember, you're going to be sliding that decimal point left or right, depending on what unit you're going to. if you notice, there's a decimal point to the right of those letters. You should always start with the decimal point to the right of the unit, and when you're going to slide the decimal point, you end to the right of the unit. Okay? So far, so good? Clear as chocolate milk? All right, let's find some examples. Okay, here we go. So we're going from 43 centimeters to kilometers. We want to convert centimeters to kilometers. So we start on the right of the number. 43 is the same as 43.0, right? So there's your decimal point right there. And you're going from centi to kilo. So you simply count. Let's skip forward here. Here's your centi right here. Start to the right where the decimal point is, and you're going to go from centi to kilo. Okay, so deci, your base unit, which is in meters this time, deca, hecto, kilo. So that's, you're sliding the decimal point 1, 2, 3, 4, 5 to the left. Okay, so we're going to do the same thing over here. You're going to slide your decimal point. Five to the left. Start here to the right of 43, and it's 1, 2, 3, 4, 5 to the left. Add your zero where there's a loop. You made a loop here. Add your 3 zeros in, so you got 0.00043, 0.00043 kilometers. So 43 centimeters, which is not very big. 43 centimeters. It's only 43 of my little fingers. If you're putting it in big terms, kilometer, remember one kilometer is a half a mile. So you're going to have a lot of centimeters to make up a kilometer. You got 43 centimeters going to equal 0.00043 kilometers. The next one, now we're going from kilograms to grams. So here's your kilos, right? Here's your prefix kilo, down to the G, which is your base unit meters, liters and grams, okay? So we're going from kilo to gram. So you take your, start on the right of kilo, and you just count hecto, deca, and grams. You're moving it 3 to the right. Put that up on the screen. Okay. So you've moved from kilo to hecto, deca, and grams, 3 to the right. So you're going to do the same thing over here. You're going to take your decimal point, 0.045, and move it 1, 2, 3 to the right, and you should come up with 45. There's your 3 loops to the right. 1, 2, 3. So hecto, deca, grams. And you come up with 45 grams. So 45 grams equals 0.045 kilograms. Okay? Kilo is a large unit. It's 1,000 grams. So you're going from large unit down to a smaller unit. So 45 grams equals 0.045 kilograms. One more. 14 liters. So you have 14 liters, and you want to know how many milliliters are in it. You're going from big to little, so it's going to be a big number. You got a lot of millis in in 1 liter. Liters is a base unit right here in the middle. So you start at this decimal point, and you're going to move it from liters down here to millis. This is milli, not meters over here. That single M in this case is a milli. These are all prefixes. So you're going deci, centi, milli. You're going to move this decimal point starting here, 3 to the right. Let's add some little loops in there. Okay? Deci, centi, milli. And you're going to do the same thing over there by the number 14. Okay? Start to the right of the 14, and you're going to go deci, centi, milli. Add your zeros in, and you end with 14,000 milliliters. 14 liters of pop, or some liquid, equals 14,000 milliliters. Okay, milli is a very small small prefix. Okay? All right. I think that's enough for today. It's about 20 minutes. If you need to go back and revisit the converting metric mania, and do those problems over, if you missed some of those or didn't understand it, give you just to review that. Again, continue to work on any work that is still out there that you haven't done or didn't understand it, and I'll give you some comments and maybe that'll help you clear it up. One big issue we had was with the roller coaster video. Okay, you need to watch the video. Everything needs to be in miles per hour. Okay, the roller coaster on the video will give you the miles per hour, or and they also give you the time. I'll give you the time. The starting speed is always going to be 0 at the top of the hill, at the bottom of the hill. And it accelerates to some speed in miles per, use the miles per hour, not kilometers per hour. And that's right at the top of the page. It explains all that. And then your units for that is miles per hour per second, okay, that it's increased by. So, for instance, top throw dragster, you go from 0 to 120 miles per hour in 4 seconds, right? That gives you 30, you're increasing in speed by 30 miles per hour every second. Okay, that's how fast your acceleration is. And so the coasters need to be in miles per hour, and that's the speed. The time is in seconds, and then your acceleration is miles per hour per second. Okay, I know a lot of people missed on that. Just some little things we need to clean up that, since I'm not there in class to explain it to you, they might have missed that. So please watch the videos because they help explain a lot of those little details. So until tomorrow, have a good day. Email me if you have any questions about anything. We'll review some of the speed information tomorrow and go from there. Have a good day.